I've been interviewing experts in mitochondria and metabolism for the Uncommon Living podcast. And here's some of the highlights that connect the dots between several of the interviews. Stephen Cunnane from the University of Sherbrooke, he tells me that 2/3 of the total metabolic throughput through the human infant, it's consumed in the brain. That should give you some idea of the importance of mitochondria to human brain development during those first 2 or 3 most critical years of life, when neurological development is happening more rapidly than at any other time. Richard Frye tells me it's not just the energy throughput of the mitochondria that are critical to brain development. The mitochondria also steer the trajectory of growth in the brain. They both power neural development and prune connections between the neurons that typically aren't supposed to be there as the brain matures. Now, Ben Bikman says that the brain prefers ketones. It has really 2 principal modes of metabolism, or that is 2 metabolic substrates, glucose and ketones. And Cunnane pointed out that a human infant is always in a state of mild or moderate ketosis, despite the lactose in breast milk, despite the glucose that the infant is taking in when it nurses. It's using up so much glucose in its brain, it is so hungry for energy, that it will always be in a state of ketosis while it's growing its brain. Martin Picard blew my mind when he said there are free mitochondria in the human bloodstream. What are they doing there? They are traveling throughout the body. He cited work that showed mitochondria can be released by fat cells, travel to the heart, and restore metabolic function in damaged heart cells. What does that tell us about the brain? Is it possible that when we stimulate via cold thermogenesis and we get our brown fat revved up so that our body makes new mitochondria, those brown fat cells are capable of releasing some of that mitochondria into our bloodstream to repair defective tissues elsewhere in the body? That seems to be the case, and there is no textbook in the world that is going to tell you that. The human brain is made up primarily of fat, and there is one fat in particular, an omega-3 fatty acid called DHA, that is critical to human neural development. So we can't make this DHA. Where do we get it? From aquatic life. I think we're all right.